Okay. Okay, looks like we're getting a few more people in, so we'll wait a few more minutes. Okay, so we're on chapter 4, which is systems of measurements. And, you know, math is all about measuring things, the number of things, the amount of things, how much space it takes up. All kinds of things require numbers. So looking at different ways that we used to measure things, we talked about Roman numerals. And one of the first systems of measurements in pharmacy is called the Apothecary System, because apothecary was the name of a pharmacy in ancient times. So, and the early pharmacists were called apothecaries too. So if you were an apothecary or a pharmacist, you worked in an apothecary or a pharmacy, and you practiced apothecary arts, which is pharmacy. So anyway, so it's gradually being replaced first with the household system and then with the metric system. Now I have dog hair on my lipstick, lovely. The metric system is the one that most of the world uses, so we eventually go to that. But in ancient times, a minim or a drop of water was considered to weigh the same as a grain of wheat. So that's the basic unit of liquid in the apothecary system, is the minim. There was something smaller actually called scruples, and scruples don't show up in this book because most, you know, they're getting to the point where we're forgetting about them. So. And the basic unit of weight is a grain, and that's because they used to actually have, you know, like a scale. Gotta have to have a pencil point. We would have a scale, and we would put little, see if I can do this and make it look a little bit better.
Like the justice system, is that what it?
Kind of. You would have these little grains of wheat, and then you would weigh your powder out to the same amount as those grains of wheat. So, you know, a scale, we use the scales of justice to represent the justice system, but before it represented justice, it was the way that they would actually weigh things.
Okay.
So a grain comes from a grain of whatever grain the area grew. So it could be wheat or barley or, you know, some other kind of a grain, rice. And so they would, it's usually somewhere in the middle of the sheath they would take the grains from, because, you know, the ones on the bottom are bigger, like an ear of corn, and the ones at the very tip are smaller. So that's where we get grain from, because they would weigh it according to how many grains of whatever this crop was that it would be the same amount of. So in different countries it would be different things. Okay, so a grain now is considered about 60 to 65 milligrams, and the reason it's 60 to 65. Oh, great, I have rainbow pen out today. Yeah, and I can't write, so sounds familiar, right? I will get used to this, this at some point. Right about the time I get used to it, it's going to be obsolete. Okay, so the reason it's 60 to 65 milligrams is because different drug companies in different countries use a different amount of weight for their grain, okay? So if you look at something like one drug that uses grains a lot is phenobarbital, but also aspirin. So with aspirin, 5 grains is equal to 325 milligrams. So the way you would write that is GRV for 5 grains. And it's 325. And I have like a button on this pen that I accidentally keep pushing. 325 milligrams or 1 regular strength tablet. So then 10 grains, 10 grains is going to be 650 milligrams. Or 2 tablets. Now, most of the time when we go into the grocery store or Target or Walmart or wherever, and we're buying aspirin, what we're going to see is 500 milligrams. So if it's 500 milligrams, how many grains is that? So we need to convert the grains to milligrams. Or we're going to convert the milligrams to grains. So how many would that be? How would we do that? Let's see. We want to know how many grains. So with aspirin and Tylenol,
I think it's 7.7.
we're going to use 65 milligrams per grain. Okay, so aspirin and Tylenol, we're going to use 65 milligrams per grain. So if we want to know how many grains it is, 1 grain is 65 milligrams, and we have 500 milligrams. Okay, so that's, we're going to put it over 1, and this is dimensional analysis because there's not an X there. Okay, so we're going to start this setup with what we're looking for, and we're looking for grains, right?
Yes.
We're looking for grains. So we're going to put the grains on top because that's what we're looking for. So 1 times 500 is 500. 65 times 1 is 65. 500 divided by 65. I'm going to get out my handy dandy calculator.
Yeah, 7.69.
And I get, yep, exactly. 7.69.
Would I be able to round up to just 7.7? Or is there a certain amount of decimals you want us to round to?
I like to see 2 decimal places, okay? But
Okay.
if honestly, if you gave me 7.6923076, it's not wrong, okay? So I'm not going to mark them wrong based on rounding unless the directions clearly say show your answer to 2 decimal places, okay? So if I ask for 2 decimal places, then I want to see 2 decimal places. If I don't have that, you know, in either the exam somewhere clearly stated, then even if you gave me 7.7, I would count it correct. Because really, okay, I'm more concerned with the process than I am with how many decimal places is in your answer. Does that make sense?
Yes.
I want to make sure that you're able to get this answer, and you don't even have to do it this way. Now, you'll probably notice that I'm not using ratio and proportion here, okay? So if I was using ratio and proportion, I'd have 65 milligrams over 1 grain is equal to 500 milligrams over X grains, right? GR, because that's gram if you don't put the R. Then I would have 65X equals 500. And then I would divide both sides by 65. And I would get X equals 7.69, whatever the rest of it is, grains. Okay, so you see the 500 over 65 here? That's exactly the same thing as this, right? So all I'm doing is taking one of them and flipping them over and multiplying. Because here what we're doing is we're cross multiplying, right, to get 65x, and cross multiplying 1 to 500 to get 500. And then in order to get x by itself, we have to multiply both sides. We have to divide both sides by 65 to get x by itself, right? Okay, so when you first learn and you learn algebra, this is what they have you do, ratio and proportion. But then as you get farther in the book, and this book shows you ratio and proportion coming up very soon, which is why I love this book. It shows you dimensional analysis, very soon. So most books just go with ratio and proportion until it gets into something that is, you're going to have to do 3 or 4 of these ratio and proportion problems in order to get your answer. Okay, so then all of a sudden it jumps into dimensional analysis, which confuses a lot of people. So this is the dimensional analysis, and your book calls it DA, dimensional analysis, okay? So what you're doing is you're taking your conversion factor, 1 grain in 65 milligrams, and you're putting whatever you're looking for on top. You're looking for grains. Then you're gonna multiply by what you already know, which is that you have 500 milligrams, and the milligrams are going to cancel each other out. So they also call this method unit cancellation method, okay? And I think they started calling it unit cancellation method to emphasize that you have to cancel the units that you don't want, but also so people didn't feel like dimensional analysis, oh my God, I must be doing calculus or something, you know, and you're not. It's still basic math. So everything that we do basically can be broken down into basic math. Okay, and most of the time, if you don't use an X, you're not even doing algebra, right? Okay, so if you're somebody who's sort of, you know, worried about math or not super comfortable with math, you know, you can still do these problems. I like to tell people, and I think I said it on the first day, we do math all the time, and we may not even realize that we're doing it, you know, like, we know, do I have enough money to fill up my gas tank? So you're comparing the money you have with how much you think you're going to have to put in your gas tank, right? Do I have enough money to go buy a pizza? What do I have in my wallet? How much is a pizza? So you're comparing the measurement of things, right? Do I have enough food to last until Friday in the cupboard? So we all do math all the time, but we might not even think about it as math. And so this is one of the reasons why I love teaching math, is if I can get people to overcome that fear or that feeling that they don't know how to do it, or they don't want to do it, or it's not fun, you know. It can be, for me, it's almost like doing a whole lot of math problems actually puts me to sleep. It's very relaxing to me. So I can't sit down and do a lot of math when I'm tired, because I will fall asleep. Okay. So anyway, so the apothecary system of measurement has these different things in it, and it goes way back to ancient times. So you have minims, drams, and ounces, and they're still found on a lot of pharmacy bottles, and medication dispensing cups. And of course, the ISMP says we shouldn't use these measurements anymore because people don't know what they are, so they're going to use the wrong measurement. But some of them are still used, like nitroglycerin sublingual tablets, nitrostat. And in the apothecary system, they use lowercase Roman numerals to mark these, and they use it with the dots above the line. So 1 grain would be GRI, like that. Okay. And then Arabic numerals can be used for numbers higher than 10, except for 20 and 30, for which Roman numerals are required. And then over the years, the line, using the line over it, sort of fell out of favor, but it's still correct to use it. Okay, so the way that and there's no decimals, okay, and there's only half. You can't have like 7 3/4 would be written like that. except for half. So with half, you would use your Roman numeral SS with the line over it. Okay. So fractions other than 1/2 are expressed using Arabic numerals, and you don't mix your Arabic and your Roman numerals. So if you're writing 7 3/4, you would not do it this way. Okay, so that is a no. So on page 84, it shows these equivalents and what they are equivalent to. So the first one is that volume of liquid, the minim, and the minim is written looking like this. But I'm not going to, once we get past chapter 4, you're probably never going to see minim again, okay? So just, you know that you need it for chapter 4, and that's about it. Now the fluid dram, which looks like that, or it could look like this if they write it in cursive writing. That's a fluid dram, and it is 60 minims. And the fluid ounce is written like this, or if they use cursive writing, see if I can do a better job at this one. So that doesn't look great either, but you get the idea. So that's an ounce. So how do we remember that this one is dram and this one is ounce? So if they write it using these symbols, then you can say that there's more bounce to the ounce. Okay, so there's an extra loop on ounce. Okay, and an ounce is 8 drams. Okay, then we have grain, which we talked about a grain. The dram is equal to, in weight, a dram is 60 grains, an ounce is 8 drams, and a pound is 12 ounces. Okay, so now if you go to some certain countries and you get a pint, you'll get 12 ounces. So if you walk into a pub, in some of the really older pubs in Ireland will still use a 12-ounce pint. But a pint in our country is 16 ounces. So when they talk about people downing a pint, well, it's not quite as large as the pints that we have here. So it just kind of depends on what country they go visit, okay? Okay, so some points to remember. On page 84, you see the green tech note. And the green tech notes are found throughout the book, and it would be a good idea to read them. Although they are not used often, the pharmacy technician should be familiar with the following apothecary equivalencies. So for weight, 1 ounce is 8 drams, and for volume, 1 ounce is also 8 drams, okay? The quantity, so the points to remember in the middle of 84, the quantity should be expressed in lowercase Roman numerals, frequently with a line placed over the entire numeral and a dot above the line with the numeral I, although this line is not used as often as it used to be. And so anyway, that's kind of what we just talked about. So keep in mind those points. And then there's a review on page 85 and then the post-test. So for this post-test, they want you to just rewrite these terms using the appropriate numerals and abbreviations or numerals and symbols with the apothecary system. So let's go back to the household system. So on page 76, it talks about the household or U.S. customary system. Now, a lot of us are familiar with this one. Household measurements and abbreviations of weight can be found on table 4.1, length in table 4.2, and volume in 4.3. So that's on page 77. So if you look at page 77, an ounce is abbreviated OZ. It doesn't show an equivalent there. A pound is abbreviated with LB or the number symbol. Now in pharmacy, this number symbol here, of course, it doesn't mean hashtag, it also means number of tablets, okay? So this can be a pound or it can be a number symbol. And then the ton is the capital letter T, which I never see anywhere else in this book. So they're not going to ask you about tons of things. And we don't normally compound medication in tons anyway, either standard tons or metric tons. So then the measurement of length is inch, the foot is 12 inches, and the yard is 36 inches or 3 feet. And then as you go down, the measurements of volume, look at the ones that are in bold lettering. The drops, GTT, teaspoon, TSP, or capital TSP, or lowercase t, those are all teaspoons. And that's the equivalent of 60 drops depending on the size of the dropper and the thickness or viscosity of the medication. And then there's a tablespoon, TBSP, capital TBSP, TBS, or capital T. And a tablespoon is 3 teaspoons. So you have a conversion sheet in your files that I provided for you guys, just like I did the Roman numeral sheet. That's going to be the one that we're going to use on the quizzes. So except for if quiz 4 is talking about apothecary specifically, I don't have a whole lot of apothecary on that sheet because we're not going to be using a lot of apothecary, not a whole lot. An ounce is 2 tablespoons or 6 teaspoons. A cup is 8 ounces. A pint is 2 cups or 16 ounces. And a quart is 2 pints or 4 cups or 32 ounces. A gallon is 4 quarts or 8 pints or 16 cups or 128 ounces. Okay, so that's the household measurement system. Household measurements are expressed in Arabic numerals with fractions for expressing parts of the whole. Like we would say a half a cup, we wouldn't say 0.5 cups. That's because most of us have measuring cups, and one of them will be a half cup. Okay, so the 60 drops per teaspoon that's often found in household measurements is only an approximation. Drops should never be used for measuring drugs unless there is a specific dropper calibrated for the medication. Like eye drops, are the dispensing bottle is the dropper also. Household measurements are often used in the home setting for the administration of medications, although they are not optimal and should be considered approximations. The use of a measurement device with the medication by the pharmacy increases the accuracy of dosing and therefore patient safety. The household system is not used in the hospital. So we never say give the patient a half of a teaspoon of medication in the hospital. Okay, I don't know if you can hear it. Bruce is barking in his sleep on the couch.
Yeah, I can.
So I hear this little, it sounds like, and that's it's him on the couch asleep.
You know, my dogs will bark at anything, so.
They do. And, you know, he needs so much attention that he has to get attention even when he's asleep. That's okay. I got him from the pound. He probably needed attention. Okay, on page 78, pharmacy technicians should commit the following basic household equivalencies to memory and can use methods presented in chapter 5 to calculate any of the others. So then that tells you about the teaspoons, tablespoons, ounces, cups, pints, and quarts. Okay, the metric system is the most widely used throughout the world, and it's most commonly used for pharmacy because it's accurate, more accurate than the other ones. Most prescriptions are written in the metric system, and most liquid drugs are administered using this system. The U.S. Pharmacopoeia considers the metric system the appropriate system to use on drug labels. Medication labels should be written in the appropriate metric units. So if you look at page 79, you see zidovudine syrup, and there's a label for it right there. So when you're looking at medication labels, you need to get used to reading the entire label because we're going to be reading these labels a lot, and you want to be able to read and understand what they say. So up in the top left corner, it says each 5 milliliters, 1 teaspoonful, contains zidovudine 50 milligrams, and I'm probably saying it wrong, but in my defense, I work with a lot of people from a lot of different countries, and I hear a lot of different pronunciations. So I tend to just grab one that's easy for me to say, and that's why I say it that way. 50 milligrams and sodium benzoate 0.2% added as a preservative. Why would it be important for us to know about preservatives? Anybody?
Because it's not effect on the medicine, like.
Well, kind of. For one thing, this bottle's going to last a lot longer because it has a preservative in it. But also, we may possibly, sometimes they use alcohol as a preservative. And if we have a little child, we don't want to give them a drug with alcohol in it. Now, yesterday at the pharmacy, at the hospital, you know, it's a children's hospital, and we usually order mouthwash. You know, there's a mouthwash called chlorhexidine gluconate, and it helps prevent gum disease and tooth decay, mostly gum disease. And so for the children's hospital, the adult hospital can use the one with alcohol, but the children's hospital does not want the one with alcohol. So what happened was our purchaser accidentally ordered the one with alcohol. So we started dispensing it and realized, wait a minute, this has alcohol. Most of the time it's not a problem because the kids that we use it with are old enough to swish it and spit it out. So they don't drink it, you know. But we do, and I thought really it's because, oh, we don't want these kids to drink alcohol, you know. But what the issue is, we have chemo patients. And when patients are undergoing chemo, they get mouth sores. Okay, so they'll have sores inside their mouth on the gums or the inside of their cheek. And these sores can be very painful for these little kids. So we don't want them to have to rinse their mouth with alcohol because it will burn those sores. And I didn't even think about that until one of our pharmacists that works on that unit was saying, oh no, they can't use this, it'll burn. And then I realized that's very true. If they have sores in their mouth, it would be like if we had a cold sore inside our mouth, it would hurt. So that's another reason that we check out the preservatives. And in the NICU, they don't want to use preservatives because they're not quite sure how these preservatives will affect the kids later, especially if they're super preemies. Does that make sense?
Yeah. Yeah.
So the last several years, all of these drug labels have been putting on the label what the preservative is or if it's preservative free. So that's a good thing. So at the top of the label, it says Knowledge Pharmaceuticals. That's an actual company. They didn't make that up. And the NDC number 6304511877. NDC stands for National Drug Code. Every drug sold in the United States must have an NDC number if it's a drug. The first 4 digits, then that can be up to 5 digits, are a code for the manufacturer. So anything that starts with 6304 is from Knowledge Pharmaceuticals. The middle 4 digits, the 5118, stands for zidovudine syrup, 50 milligrams per 5 mLs. Okay, so it stands for the drug name, form, and strength. Okay, and then the last 2 digits, 77, in the case of this drug company, it stands for 240 milliliters. So it's the package size. Okay, so we need to know those things. Then it has the name of the drug, and on the left side in the middle, it says see package insert for dosage and administration, and it says store at 15 to 25 degrees Celsius, and then it gives you the conversion to Fahrenheit too. Then you have the drug name in the middle, 240 milliliters, and it says RX only, which means what?
Prescription only?
Yes, so the person that gets this medication has to have a prescription for it. Then we have a lot number and we have an expiration date. Now the lot number could also be called a batch number because it tells the drug company that made the drug, it tells them which of their factories it was made in and which batch it is. And then also the expiration date is a legal thing. Does that mean on September 1st of 2021, this is going to turn into a pumpkin? Like Cinderella?
No.
No, of course not. But legally, they're not going to guarantee anything after that date. And legally, it expires August 31st at midnight. So it goes all the way through August up until midnight, and then of the last day of the month. So that's how you read those, and that's why they don't have to have a day. Now, if it's a shorter stability drug and they have to put a day on it, then that's the actual expiration date, not the end of the month, okay? And then the B555646, I do not know what that is, but some labels will have weird stuff on it that I don't know what it is. But by law, except for that B555646, everything else that's on there has to be on every drug that's sold in the US. Is that making sense? Like in the bottom left corner, Knowledge Pharmaceuticals, St. Louis, Missouri, and a zip code. So they have to put either where it was made or where the company that is selling it is located. Okay, so you can kind of tell where your drugs come from. Not always, because sometimes they'll have someone else make them and then they'll sell them as theirs. Okay, now you have digoxin labels. The digoxin label on the bottom, on the left-hand side, says 125, and then there's a thing that looks like this. Okay, so it looks something like that, which stands for micrograms. You might also see micrograms written like this, which kind of looks like minims, but that's another way to write micrograms. Okay, and I think in actuality it won't have such a long loop, it'll have a smaller loop, like that. And a microgram is 1/1000th
milligram
of a gram. Good. So if you look on the top of page 80, all of the metric systems have a base unit of measure, which is the gram, or in case of weight, it's the gram, or it could be kilograms. So as it goes up in weight, you have these prefixes, deca, hecto, and kilo. So if you have 10 grams, technically you have a decagram, 100 grams is a hectogram, and 1,000 grams is a kilogram. And the only one we use in real life as far as saying it that way is the kilogram. Otherwise, we're just going to write out 150 grams. We wouldn't say a 1.5 hectograms. And then as you go down, 1/110th of a gram is a decigram, 1/100th of a gram is a centigram, and then 1/1000th of a gram is a milligram, and the milligram is the one that we use most often. And then they don't have the units for 1/10,000th and 1/100,000th. They only have the prefixes for the micro, which is 1/100,000th of the milligram, which is the microgram. Oh, see, I did this wrong. It's not, a microgram is not 1/1000th of a gram, it's 1/1000th of a milligram. Okay, so now in order to, go ahead. Saja, did you have something?
No, thank you. No.
Okay. Okay. So in order to give everybody an idea of this, what I did with one of my classes, and we had 4 hours of lab a day to do stuff in, so they ended up making a lot of lip balm and hand cream, which they wanted to do, so I let them, as long as they did the other stuff too. We took salt and we poured salt out and we weighed 1 gram of salt. Okay, and then I had 10 people around a table. So we took this and we basically dumped it out in front of them in little piles until they all had a pile in front of them. And I said, okay, count how many grains of salt are in your pile. And they were just astonished. Like, I don't want to count grains of salt. That's going to take me all afternoon. But it really didn't. It didn't take that long. And what we found out is that a milligram is the whole gram of salt was about 1,500 grains of salt. Okay, so if there's 1,500 grains of salt, not the apothecary grain, but actual grains of salt, in a gram, and this is the salt like that you buy with the little girl with the umbrella on her back, Morton salt. So that's how thick it's ground. So it's not big kosher salt, and it's not super fine salt, it's just regular salt. So then that means that there's 1.5 grains of salt in a milligram. Right? Does that make sense? So when people wonder how big is a milligram, if you want to picture it in your mind and think of how much it would weigh, it's about 1.5 grains of salt. So now we have a visual comparison in our mind, right? Okay. So, you know, for me, I think that was helpful because when we think about milligrams, that's how tiny they are. But if you put that 1.5 grains on your tongue, you can taste it. It has an effect on your body, right? So when we're talking about very powerful drugs, some drugs are so tiny that 1.5 grains of salt is the same thing as 1,000 micrograms or 1,500 micrograms in that 1.5 grains of salt. So that gives us an idea of how very, very powerful some of these drugs are. Like digoxin is in micrograms. So you go back to page 79, 125 micrograms or 0.125 milligrams is all that drug needs to help people's heart beat stronger without beating faster. So I think that's a good imagery, and you know, so I like to use that one. Okay, so then on page 80, table 4.4 gives you the metric system of measurements, 1,000 units. And units, we're not talking about units of vitamin D or anything like that, not international units. But 1,000 of these grams would be a kilogram if the base unit is a gram. And 1,000 units of a liter is a kiloliter. Or 1/1000th of it is a milliliter. And then the length is a meter. So if you have 1,000 meters, you have a kilometer, or like we call it, a kilometer. The volume of liquid, our main measurements are going to be liters and milliliters. So if you have a whole big bag of fluid, most of the time it's a 1 liter bag of fluid. But if you're going to give a patient a small amount of a drug, you're going to measure it in milliliters. So a lot of times what we do is we take a small vial of potassium chloride, we take out 10 milliliters, which is 20 milliequivalents of potassium, and we add it to a 1 liter bag. And that'll take a few hours for the patient to get instilled into their bloodstream, and then, or infused into their bloodstream, and then it helps raise their potassium, which is an electrolyte, and, you know, hopefully helps them feel better and be hydrated. Okay, so another way that we express a milliliter is a cubic centimeter. 1 cubic centimeter is the amount of space that's required to hold 1 milliliter of liquid. The abbreviation cc is not recommended because if you write it very quickly, it could look like 00. Okay, so we don't want to use cc in our writings for that reason. So we're going to use milliliter, but not cc. Okay. And again, we don't want to use the abbreviation microgram because it would be very easy to confuse it with milligrams. So we want to spell it out instead of microgram like that. We're going to do mcg for microgram, and make sure that you can see the C, because if you can't see the C, then what does it look like? Milligrams, right? And then you're overdosing someone by 1,000 times. So it's important to have a general idea of the weight, volume, and length of the unit. Most people in the US are familiar with household, but not metric units. So here's some comparisons. A gram is about the weight of 2 large-sized paper clips, and a liter is about the size of a quart container, and a meter is 3 inches longer than a yardstick. And of course, we're going to use decimals for fractions with the metric system. Okay, so on page 82, you have tech notes. Pharmacy technicians should commit the following basic metric equivalences to memory and can use methods presented in chapter 5 to calculate any of the others that are needed. This is very, very true. You need to know these things, whether you're going into pharmacy or nursing or anything having to do with medicine. You need to know that there's 1,000 micrograms in a milligram, 1,000 milligrams in a gram, and 1,000 grams in a kilogram, and the volume 1,000 milliliters in 1 liter. Okay, so that you need to have that memorized. And it's important to note, when my kids were born, let's go through the conversion factor real quick for kilograms and pounds. So my second son was 9 pounds 12 ounces, which is 9.75 pounds. So how much is that? So if we're going from kilograms to pounds, 1 kilogram, 2.2 pounds times 9.75 pounds over 1. He was late too, so basically
4.4.
he sat there and grew. 4.43 pounds, or kilograms, right?
Yes.
4.43 kilograms. We have babies so tiny. We have had 23-week preemies, which means that instead of being in the womb for 40 weeks, they were only in there for 23 weeks. So not even, or barely a little more than half the time they should have been in there. They are so tiny that we measure them in grams instead of kilograms. They're not even a pound. They're not even a half a pound. So some of those babies are like 900 kilograms. I mean, 900 grams, which is 0.9 kilograms. So they're not even a pound. Very, very tiny. Okay, or they're not even 2 pounds, I should say. And there are some that are below a pound too. And then we talked about a leading 0 and a trailing 0, right? Which one is okay to use?
We need to use the leading 0.
The leading 0. So this one's 0.9 kilograms. We wouldn't put just 0.9 because they might not see that little decimal place, right?
Yes.
But if we wanted to say 9 kilograms, we would not write 9.0 kilograms, right? Because what if they didn't see that little tiny decimal point?
Yeah.
It could be extremely tiny. And if they don't see it, then they think it's 90 kilograms, right?
Right.
Okay, so we don't want to use the trailing 0, only the leading 0. Okay, look on page 83, and I'm glad that Elaine Beale brings this up right here in chapter 4. Nitroglycerin tablets. Nitroglycerin tablets are another drug that's extremely strong. And do you guys want to hear the story of nitroglycerin tablets?
Yes.
Yes.
Okay. Okay, so nitroglycerin.
Which page? 84?
83. Page 83.
Oh, thank you.
Okay. Nitroglycerin is explosive. It's explosive. They use it in making dynamite or TNT. So what happened was about 135 years ago, which would put it around the late 1800s, there were a group of miners, and I don't even remember where they were. That's how bad I am with these stories. Okay, but they would work in the mines and they would do 12-hour shifts most of the time, and they would sometimes work 6 days a week. And what happened was some of the older miners would be working all week, and on Sunday they would wake up and not go into the mine because it was Sunday and they weren't allowed to work on the Sabbath. And they would start to have chest pain toward the end of the day. And then they would go into work Monday morning and feel better. And finally, one of the doctors in the area decided to investigate why this was happening. And they discovered in doing this that the nitroglycerin, the dynamite that they were using to blast through new areas of the mine, was actually having an effect on the miner's heart. So they started making this nitroglycerin tablets out of it. And nitroglycerin tablets, they open up the blood vessels so that more blood can go through. So it's used for angina or angina pectoris, which is chest pain due to the blood vessels constricting because the nitroglycerin opens it up. So they came up with these 3 strengths. There's 0.2, 3, and 4, 0.3 milligrams, 0.2 milligrams, and 0.4 milligrams. And so the 0.3 milligrams is 1/200th of a grain. But technically we should be writing the grain symbol in front of the 1/200, okay, if we want to do it correctly. But you'll still see this grain marking on the label of the nitroglycerin tablets. And so they put it under their tongue, and so the directions are supposed to read, place 1 tablet under the tongue every 5 minutes for 3 doses. If there's still chest pain, call 911. Basically, that's what they're supposed to say. Because when they put it under the tongue, it goes in the little capillaries and goes straight to the bloodstream, and then you should not feel the chest pain. So if you do that 3 times, it's like you do one, wait 5 minutes, you do one, wait 5 minutes, and you do one, you wait 5 minutes. That's 15 minutes. So if someone is having chest pain for 15 minutes, they should probably call an ambulance, right? Maybe they're having a heart attack. So, so that's the strength of nitroglycerin, and this comes up a lot of times on national exams for nurses and for technicians. So let's see what the conversion is for the 0.2 and the 0.4 milligrams. This one uses 60 milligrams per grain. So 1 grain is 60 milligrams times 0.2 milligrams. So we have 1 times 0.2, and 0.2 divided by 60. Let's see if this is how we're doing it. Yeah.
0.0.03.
Okay, so what we get is a decimal, but we want to put this in this format with the, we want to put it in the fraction format. So if we were going to put it in the fraction format, we'd have to take the 0.2 times something to get 1.
0.2 times
5, right?
5. Yes.
Times 5 is 1 over, and 60 times 5.
300. No.
300. So it's 1 over 300. Okay. And then the 0.4 is going to be twice as strong. So this one is, let me see. This one is 1 over 300 grains. 0.4 is twice as strong, so it's going to be 1 over 150 grains. Okay, so these are the 3 strengths of nitroglycerin that are available. Is this making sense? If this is twice as strong, it's going to be divided by a number on the bottom that's half as big.
So like we divided by 2. The 300 we divided by 2.
Yes, because you're multiplying the strength by 2, so the number on the bottom needs to be divided by 2.
By 2. Okay.
Okay, all right. So that's the conversion there. Now, most of the time, what you're not going to see that. What you're going to see is nitroglycerin, 1/150th of a grain is equal to how many milligrams? So in that case, what you're going to do is take the 60 milligrams over 1, should say grain, times 1/150, which is going to be 60 divided by 150. Which gives you 0.4 milligrams.
I don't get that, the last one.
Okay, so this is the problem that you'll get on these exams, right? So if there's 60 milligrams in 1 grain, what we have is 1/150 grains. 1/150th. So it's basically 60 milligrams divided by 150. Okay, so you're multiplying, instead of multiplying, you know, cross multiplying like
Yeah,
if we had,
I get it.
yeah, we're not doing ratio and proportion, so we're not going to cross multiply. We're just going to straight across multiply. So 60 times 1 is 60. 1 times 150 equals 150. Okay, because what this means right here is 1 grain divided by 150, right? So that's why we write it this way. And then when you do your multiplication, you want to make sure you keep this 150 on the bottom. So it comes out to 0.4 milligrams. Okay.
So the smaller the milligrams, the higher the strength?
Yes, so the smaller the number on the bottom, the higher the strength. So 0.4 is going to be 1/150. 0.3 is 1/200, and 0.2 is 1/300. I know we're looking at these numbers going, why don't these numbers get bigger? When you divide by a large number, you have a small outcome. Okay, so the higher this number here, the smaller this number is. And the smaller this number is, the higher this number is.
And Mrs. Lopez, I have a quick question about that last equation.
Yes, this one?
Correct. So
Okay.
same concept when setting it up with a dimensional analysis where you just cross off the like the grams on that case, and then you're left with milligrams.
Yes.
That's what you're looking for. Okay. Got
Yes.
it. Thank you.
Okay, so another way you could do this is they're using 60 milligrams in a grain, right? Yeah, let me not use this one. Okay, so we have 150, 1/150th of a grain, right? So 1 divided by 150 times 60. Okay, so what we're doing is we're taking this number here and we're turning it into a decimal first. 1 divided by 150 equals what? Let me get my calculator. And I get 0.006666, and it repeats. But then if I don't if I just go straight into times 60, I'm going to get 0.4. But what I actually get is 0.39999 repeating, which rounds up to 0.4. So, and that's because this up here is, you know, a fraction, and I'm trying to turn it into a decimal. So it's going to give you a lot of repeating numbers, and that happens a lot when we turn fractions into decimals. So, you know, at this point we can round. Okay, so that's another way to do it. Take the top divided by the bottom and multiply by 60. So if we do this using, say, 0.2 milligrams, which is 1/300. One divided by 300 times 60. What do we get with that one?
0.2.
And the 9999 just keeps repeating. So it's going to be 0.2 milligrams. And is that what we said up here? Yep,
Yes.
0.2. Okay, so that's another way to do these. And when I was talking to you guys the very first day, there's more than one way to do these problems, and you can clearly see that here. You've got this whole setup, and then you've got this. So either way, you know, you're going to get the correct answer, and that's the important thing. So whatever answer looks good to you is, you know, what you should use. That method, whatever works in that method is what you're going to use. So I've had several people turn in the Chapter 4 post-test. The post-test for this one is not doing, well, it's rewriting the appropriate numerals and abbreviations, and then it goes into equivalencies. Okay, so that kind of gets you set up for conversions within the measurement systems, which is Chapter 5. And if you want, we can go into that because, what time is it? Well, it's 3 o'clock, so we've been here for an hour. How do you guys feel about going into Chapter 5?
Can we not, please, because I have so much homework this week, so much homework.
Well, if the homework isn't due yet.
Okay, if there's no homework, I am fine, but.
Well, you can, I leave the post-test open for a while, like 2 to 3 weeks, because I know you guys have other homework too, and you know, you have kids and families, and you probably have a dog jumping in your lap sometimes, so, you know, things happen. So I leave the homework open. I put an end date on the homework only because for some people that don't do any homework until the last minute, I don't want to get 17 chapters of homework on December 10th, okay?
Oh.
I'm going to have to look at it. I'm going to have to check. By the way, do you guys see the file I placed in there with the key on it?
Yes.
Yes.
Okay, so now the key is mostly correct. I think we've found 2 or 3 in the last year when I've taught this class. We found 2 or 3 instances where the key is wrong. So let me know, because when I emailed Elaine Beal about this book, I told you I wrote her a fan letter, right?
Yes.
I told you that. I love this textbook. She asked me to tell her what my students have found as far as inaccuracies and typos, okay? Because she's working on the 4th edition right now. So, and I might actually get to see it before it's published, which some people are going to be like, if they have an author that they've talked to and that author sends them an advanced copy of their novel, they're all excited. This is a math book and I'm excited about getting an advanced copy because I'm such a nerd. So anyway, I might get to see it. That would be cool. I might even get to review it. We'll see. So Chapter 5 talks about what we just did. With all of this, it talks about conversions within the measurement systems, but I promise you, this is the hardest one in the whole chapter, okay, for Chapter 5. What we just did was the hardest one. Now, look at this mess that I just showed you guys, right? All these different colors and things. Imagine me doing this on a whiteboard in the classroom. This is how I work. I have to have 4 or 5 different colors of markers on the whiteboard. Okay, so this is the hardest thing we're going to do as far as the conversions, okay? The fraction conversions are a lot more difficult for some people. So look on page 88, just to give you a preview. Where it says keywords, conversion factor. A conversion factor is a ratio equal to 1 that's used to change one unit to another without changing the value of the answer. So let's look at this for just a minute. Let's look at page 89 in the pretest number 11. I just had an ice cream truck go by. I haven't seen one of those in a while. 0.125 milligrams equals blank micrograms. So our ratio is going to be 1 milligram to 1,000 micrograms. They're equal to each other, right?
Right.
So I can also make it a fraction, right? 1 milligram over 1,000 micrograms. And they're equal, so they're the same thing. So doesn't this mean, since they're the same thing, that they're equal to 1?
Yes.
Yeah, they're equal to 1. So now I can take this and I can also put the 1,000 micrograms on top and the 1 milligram on the bottom. Yes?
Yes.
Okay, they're exactly the same thing. So now I can take this number up here and I can multiply it by this, can't I?
We can, yeah.
Yeah, and what I'm going to end up doing is converting these milligrams to micrograms. So we have 0.125 milligrams. I can put it over 1. I can make a fraction out of it, and I can multiply by 1,000 micrograms over 1 milligram. And just like where you have 1 over 1 equaling 1, I can have milligrams over milligrams and they will cancel each other out.
Yes.
Okay, so 0.125 times 1,000, I'm going to move the decimal point 3 places, and I have 125 micrograms. Okay, now when I usually set this up, I take the conversion factor here and I put it first. I start with it because a lot of people don't know, do I want this one with the milligrams on top or do I want this one with the milligrams on the bottom? So I'm going, what are you looking for? You're looking for micrograms. So let's use this one because the micrograms are on top.
Yeah.
Okay, so I will set this problem up with the conversion factor first. So with the conversion factor first, it's going to look like 1,000 micrograms because I want to end up with micrograms over 1 milligram. And then multiply it by 0.125 milligrams. And I can put it over 1 to make it a fraction. You don't have to write the 1. And this is going to tell me to multiply by 1,000. Because a lot of times we know there's 1,000 of something, right? So I'm either going to have to multiply or divide by 1,000. How do I know which one to do? So you could look at this and go, well, I'm going to the smaller unit, so I need more of them, so I'm going to multiply. But a lot of people don't get that. They say smaller unit, you have to divide. So it's confusing for them. Setting it up this way gives you The micrograms are what you want to end up with, so it tells you to put the 1,000, the micrograms on top, which are 1,000, so that tells you to multiply by 1,000. Is that making sense? Okay, so that's why we use this dimensional analysis, because if we start with what we're looking for, everything else is going to cancel out, and that's what we'll end up with.
So like you said, the smaller unit you would multiply. So if we go into a larger unit, you would divide?
Exactly. Yes. Is that making sense?
Yes.
Okay, good. All right, so that's basically chapter 5 right there. Every problem you're going to multiply by 1,000. No, wait, that's not right. You can't do that on every problem. Okay, so what you're going to do is you're going to look at page, well, you're going to look at the chapter and find the equivalencies, and then you're going to multiply by the equivalency. Now on page 99, it gives you ratio and proportion, and it gives it to you in Roman numerals. Whenever I do math with Roman numerals, I convert them to Arabic numerals first. Okay, I do not do math with Roman numerals. Oh, I didn't finish telling you the nitroglycerin story. That was only part of the story. That was only the first half of the story. Okay, so I'm going to finish it. I'm sorry, guys. I'm going to finish the story. Halfway through the first decade of 2000, sometime around 2006 or 2007 in there was this very small article in the newspaper that said, after 125 years, MOA of nitroglycerin is discovered. And most people are going to be like, what the heck is that? And nobody really read this thing. But of course I went, nitroglycerin, that's a drug. I'm going to read the story. And because these companies like Knowledge Pharmaceuticals had been putting out nitroglycerin for so many years, and it had a strong history of, we know it helps pain from, and we know that it opens up the blood vessels, okay? Because of that, the FDA did not require double-blind controlled studies. So none of the drug companies that manufacture it were going to pay to find out exactly what the MOA is. So the MOA stands for mechanism of action. And I keep pushing the wrong buttons on this thing. So what that means in drug terms is, where does the drug, the chemical particle of the drug, attach to the cell? And what does it do once it gets inside the cell? Is it a blocker that blocks something else from getting in, or is it something else? So because none of the drug companies were doing this, a university decided to take it on as a project, and they actually figured out the mechanism of action. How does it work? So now, and I don't remember how it works now, that's the bad part of the story, so I can't tell you that it is a receptor antagonist or if it's a receptor agonist. I don't remember, okay, so I'll be honest there. It wasn't that important to me. What was interesting to me is that we use this drug for 120 years without even knowing how it works. So all the new drugs that come out on the market, they have to show their mechanism of action. And sometimes they don't know, but they have to have a theory. Hold on just a minute. Let me see what's going on with my phone. Sorry, I know all of you guys get spam calls too, and my phone was taking a message, but it was a very long message from spam, so I don't want that. Okay, so the idea that we could use a drug for 120 years without knowing exactly how it works is just, you know, it's amazing to me. And so it was pretty exciting that we figured out how it worked. And it was a university students that made it a project and figured that out. So that's pretty cool. Okay, do you have any other questions on chapter 4?
No.
No.
I have one question, please.
Okay.
You said that a grain maybe 60 or 65 milligrams. So
Yes.
when we convert, which one we should use?
Okay, so you're going to use 60 milligrams to 1 grain,
Grain. Oh.
except for Tylenol or aspirin. Okay, and the generic name of Tylenol is acetaminophen. Okay, so, and it's also, aspirin has an abbreviation. The aspirin abbreviation is ASA, which stands for acetyl salicylic acid. The acetaminophen is APAP, which stands for its very long chemical name. But in Europe, the generic name is not acetaminophen, it's paracetamol, which I think is interesting that it would have a different generic name in other countries. And I think it's spelled something like that. I'm not sure of the spelling, okay? And it might even have another generic name, and I can't remember what it is. And it might be a branded thing that it's sold by. So, you know, Tylenol is really big in a lot of countries. So, is it the same thing as aspirin?
I think no.
No, it's not exactly. Aspirin is an anti-inflammatory and a blood thinner. And then it also treats pain and fever. So Tylenol treats pain and fever, but it's not an anti-inflammatory and it's not a blood thinner. And it's easier on the stomach than aspirin. So that's why it's so popular, mainly because it doesn't cause ulcers like aspirin can if somebody uses it a lot. Okay, does anyone else have any questions on chapter 4?
No.
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 Okay. So I'm going to go ahead and post this meeting on the YouTube channel. Are you guys able to find that? Were you able to find the YouTube channel?
How exactly do we access it?
Yes, I was able to.
Was that Ruben? What did you say?
How exactly can you access the YouTube channel?
In Canvas, there's a link. And it's also, if you were to look for it, there's a lot of Kim Lopez's on YouTube. Don't look at any of those, okay? Some of them are not appropriate. I'm in there under Kim Lopez Instructor. Okay? I'm just being honest with you. Some of them are kind of, here's me in a bikini, but that's not me. Okay. Also, how is the homework coming? You guys turning in homework?
Yes.
I
Yes.
just started 3.
Yeah.
Going all right.
Okay,
I took the quiz also.
good, good.
I turned
So,
chapter 3 because it said it was due today.
okay. So the due date is when I like to see it, because basically if you stick to the due dates, then you're going to be on track. If you wait until the closing, which is, like, I won't accept it after, it's usually 2 weeks after that, then you're going to get behind. So it's best to turn it in during, by the due date. I'm not taking points off for late as long as the time period hasn't closed, okay? So I'm just basically trying to keep everybody on track. But know this, the drop date is coming up. So if you know someone that hasn't turned in any homework and doesn't come to these Zoom meetings or anything like that, and they're thinking they can wait till the last minute, I'm going to have to drop people. I'm going to email all of them that haven't turned anything in, because that shows no attendance. Okay. And this is the only way that we can track attendance, because I'm not actually writing you down on as far as attending these meetings. Okay. The meetings are for you, to help you understand the content. Okay. But I'm not taking that as attendance, because some people can't come to these because they're at work at this time. Right. Okay, so I'm going to have to drop people that don't turn anything in. I'm going to email them and give them a chance to turn something in, or to let me know that they're still in class. But since it's online and I'm not standing in front of you guys taking attendance, I don't want someone to pay for a class that they're not taking anymore, but they forgot to drop it, right? So I'm going to ask them if they want to drop it. So that's what I have to do this afternoon. So, because it has to do with whether they get a refund, whether they get a W on their transcripts, or whether they get an F on their transcripts. And I'd rather have nothing on my transcripts, or at the very least a W if I'm not going to take a class, right? I certainly wouldn't want an F because I forgot to drop the class. So that's what I'm looking at there. Okay. Any other questions?
Oh, thank you.
Okay, so,
Thank
all
you.
right. And you guys know you can email me, right?
Yeah.
Yes.
Okay, good. All right. Thank you for showing up.
You're welcome. Thank you. Bye.
Bye.